All right, in the last lesson, we practiced multiplying radicals using the distributive property, and we just distributed one thing. Today we have two things to distribute. Sometimes when we're in class together, I call that double distributive property or double distribute. It's most commonly referred to as FOIL. Remember, FOIL stands for first, outside, inside, last. And it's talking about the placement of the terms in your problem. So if you look at number 1 here, if you're doing the F for FOIL, you multiply the first terms together. If you're doing the O, that's for outside. That's this one on the far left and this one on the far right. I is for inside. That is the inside terms here and here. And then L is for last. That's the last terms in each binomial. It would be this one times this one. So that's what FOIL stand for. You're welcome to do it like that. What you usually see me do is just distribute twice. So here's what I mean by that. Imagine for a minute that this part, let me see if this is going to work, that this part is not even here. Okay, that sucked. That's almost worthless. Here, imagine that this wasn't here. Okay, now it's just a distributive property like we did in the last lesson. You just distribute the 3 through. You do that math. 3 times 4 is 12. 3 times -2 is -6, and then you add the square root of 7 onto there. Okay. Now imagine, now that we're done with the 3, we'll go back to that second term that we hid for a second. Now imagine the 3 is not there. And now you're distributing the -2 radical 7. So then -2 radical 7 times 4 is -8 radical 7. And then look at these two. So here's where we are now. We're going to multiply that. So remember when multiplying radicals, this is from last week, you multiply what's outside and you multiply what's inside. So the outsides are -2 and -2. That's +4. The insides are 7 and 7. Not to drink because y'all are not 21. Ah, dang it. Dang it. Oh my goodness, are you kidding me right now? Okay, so this was step 1, distribute both radicals. I did double distribute, or you could do FOIL. Each way, you're going to end up with the same answer. Now we simplify radicals and combine like terms. I'm going to sort of do both of those together at the same time. So we can go ahead and combine some terms right now. We can combine these two because their radicals are the same. They're both square roots of 7. So we do the math on the coefficients, -6, -8. So -6 rad 7 minus 8 rad 7 is -14 rad 7. The 12 I'm just going to bring down. It's all alone. Nobody goes with it right now. And then let's talk about the 4 square roots of 49. The square root of 49, 49 is a perfect square. So this simplifies completely, meaning the radical goes away entirely because the square root of 49 is 7. And it's being multiplied by the 4 that's out front. And it's positive. So that 4 times 7 is going to give me 28. Well, there's no radical on 28. and there's no radical on this 12. So these two things can combine because they're like terms. So that's 12 plus 28. So 12, that's 4 times 7 is 28. We're going to add that to 12, we get 40. And then we still have that minus 14 rad 7. That doesn't go with anything. And so we have that answer right there. 40 minus 14 square roots of 7. Okay. I want you to go ahead and try number 2 before you continue the video. In fact, numbers 2 and 3 are just like number 1. So I'm not going to put those in the video. I want you just to try them by yourself. And you can look at the completed notes sheet, the PDF that I have attached to the agenda. You can look at that for the solution. Let's skip down to this section. These three problems are also very similar. So I'm just going to do number 4 for you. And that way the video will be nice and short. And then you can go finish 5 and 6 on your own. I don't feel like you're really missing out with me not having all 3 in the video because they all work exactly the same. So let's talk about number 4. So for double distribute, I'm going to take this first term and distribute it through. That gives me, notice these have variables in them, but we can handle that. So for the first one, I have cube root of x times x, which is x squared. And then distributing it to the 4 gives me 4 cube roots of x. Right? So now I'm going to distribute the negative 2 to this first term. That's negative 2 cube roots of x. And then I'll distribute negative 2 to the 4. So that's negative 8. So let's talk about what we can simplify and what we can combine. In the first radical, the cube root of x squared, remember, because it's a cube root, you're looking for a group of 3 things. Well, I don't have that because there's only 2 x's inside the radical. So that means this can't simplify at all. So just going to stay cube root of x squared. These next 2 terms, notice that they have on their radical, it's the same root and the same radicand. Right? They're both cube roots. They both have x inside. So we can combine those. That's addition and subtraction problem. So the math is going to happen on the coefficients. Positive 4, negative 2 is plus 2. And when you're adding and subtracting, the root and the radicand stays the same. I had 4 cube roots of x. I took away 2 cube roots of x, so I have 2 cube roots of x left. And then you just have this minus 8. So now we look and see if we can combine anything else. 8 can't combine with anything because there's no radical on it. We can't combine, these 2 are not like terms. They have the same root, but they do not have the same radicand. Their stuff inside is not the same. So that's it. We're done. So it's like a really ugly answer, but it was actually a pretty fast and simple problem because there wasn't too much math left to do. So go ahead and finish out the rest of those and check your work with the PDF in your Google Classroom that has the completed solutions.